Hello. In this video, we're diving into the AWS Well-Architected Framework, which is a tool that helps you build secure, high-performing, resilient, and efficient infrastructure in the cloud. Whether you're just starting with AWS or looking to optimize your existing setup, this framework provides key principles and best practices across 6 pillars, which we will discover in a moment. By the end of this video, you'll have a solid foundation for designing and managing cloud workloads that meet your business goals. I will focus on the design principles and provide concrete examples how to implement them using AWS services. Let's get started and look into the pillars. The first one is operational excellence, and this pillar focuses on running and monitoring systems effectively and continuously improving processes to deliver business values. So let's take a look at the design principles. There's 5 of them. And the first one we can see is perform operations as code. So to do that, we can use AWS CloudFormation to define our infrastructure and operational procedures as code. And this should enable us to automate deployments and changes. The second one, make frequent, small, reversible changes. We can leverage AWS Code Pipeline and AWS Code Deploy to automate the deployment of small changes, making it easier to roll back if necessary. Then refining operations procedures frequently. For that, we could use AWS Config to continuously evaluate and refine our configurations, ensuring they remain compliant with best practices. Up next, anticipate failure. And to anticipate failure, we could implement AWS autoscaling and AWS elastic load balancing to anticipate and manage failures by automatically adjusting capacity for our servers. And last of this group is learning from all operational failures. And here I would suggest using AWS CloudTrail and Amazon CloudWatch. Here we can see logs that record and analyze all our operations, facilitating post-incident reviews and continuous improvement. The second pillar is security, and the security pillar ensures that our systems and data are protected through preventive measures and continuous monitoring. So again, let's take a look at the design principles. There's 7 of them this time. And the first one is implement a strong identity foundation. Here we should remember to use AWS Identity and Access Management, IAM, to control access with policies, roles, and multi-factor authentication. Then enable traceability. We should leverage again, AWS CloudTrail to monitor and log all account activity, which should provide traceability for actions taken in the AWS environment. Next, apply security at all layers. We should implement security controls at every layer using services like WFA, AWS Shield, and Amazon VPC security groups. Next, automate security best practices. For this, use AWS config rules and AWS Lambda to automate compliance checks and enforce security best practices. Up next, protect data in transit and at rest, which means that we should encrypt data using the Key Management Service, KMS, for encryption at rest, and enforce the use of HTTPS with Amazon CloudFront for encryption in transit. The following principle, keep people away from data. For that, we should utilize AWS Systems Manager for secure, auditable access to our instances without direct access to the underlying operating systems. And last but not least, prepare for security events. That means we should develop an incident response plan using AWS Security Hub to centralize and automate security alerts and response actions. So that's it about the security. Let's move on to the next pillar. And the third pillar is reliability. It ensures that our workloads perform their intended function consistently and that they can recover from disruptions. And to achieve that, let's look at the design principles we should rely on. And the first one is automatically recover from failure. So let's use Amazon RDS multi-AZ deployments. So we deploy in multiple availability zones in order to achieve automatic failover of the database instances. Then test recovery procedures. We should regularly simulate failures with AWS Fault Injection Simulator to test the recovery processes. Up next, scale horizontally to increase aggregate workload availability. We should implement Amazon EC2 autoscaling to distribute workloads across multiple instances and improve availability. Stop guessing capacity. Use AWS autoscaling and Amazon DynamoDB autoscaling to dynamically adjust resources based on demand. And the last design principle, manage change in automation. We should automate change management with AWS CloudFormation to manage infrastructure changes predictably. Moving on to the next pillar. Here we have performance efficiency, very important pillar, which focuses on using computing resources efficiently to meet system requirements and also to adapt to changes in demand. So let's look at the design principles and implementation. What can we do to democratize advanced technologies? For example, we could use AWS Lambda to offload tasks to serverless architectures, enabling us to experiment with new technologies without managing infrastructure. Then go global in minutes. We can deploy applications globally using, for example, Amazon CloudFront and AWS Global Accelerator in order to reduce latency for users worldwide. Using serverless architectures, again, as I said before, we can use AWS Lambda, AWS Fargate, S3, so the simple storage service, to build applications that scale automatically based on demand. We should experiment more often, for example, using AWS CloudFormation stack sets, so that we can test new configurations across multiple AWS accounts or regions. And the last thing that we should do for performance efficiency is considering mechanical sympathy. What does it mean? That means we should optimize performance by selecting appropriate instance types with AWS Compute Optimizer, ensuring that our workloads run on the best suited hardware for us. Then pillar number 5, this is cost optimization. The cost optimization pillar aims to deliver business value at the lowest possible cost by managing our resources efficiently. So that's pretty straightforward. Let's look at the design principles. Implementing cloud financial management. What could we do? We could use the service called AWS Cost Explorer or AWS Budgets. This way we can monitor and optimize the cloud spending. Adopting a consumption model, we can utilize EC2 spot instances or AWS autoscaling. This way we can pay only for the resources that we actually use, and we can scale down during off-peak times. Third principle, measure overall efficiency. For that, we can implement the AWS Trusted Advisor checks to identify underutilized resources in order to optimize their usage. Then, stop spending money on undifferentiated heavy lifting. We should use managed services like, for example, Amazon RDS or Amazon Fargate to avoid the overhead of managing infrastructure. And the last one is analyze and attribute expenditure. So, for example, we could use the cost and usage reports to track spending and attribute costs to specific business units. And let's finish this off with pillar number 6, which is sustainability. And the sustainability pillar focuses on minimizing the environmental impact of cloud workloads over their life cycle. Let's take a look at the design principles and implementation. First, understand your impact. For example, use the AWS Customer Carbon Footprint tool to measure the carbon impact of your cloud usage and identify opportunities for reduction of that impact. Then, establish sustainability goals. And it tells us that we could set and track some sustainability targets. For example, leveraging AWS tools to reduce the environmental footprint. Then maximize utilization. Let's optimize the resource use with AWS Compute Optimizer and right-size instances to avoid over-provisioning. Next, we can anticipate and adopt new, more efficient hardware and software offerings. We should regularly review and adopt more efficient AWS services, such as moving from EC2 instances to AWS Graviton-based instances, or consider other options. Then we can use managed services. We can rely on AWS managed services like Amazon Aurora or AWS Lambda to reduce the overhead of managing physical resources and improve the energy efficiency. And last but not least, reduce the downstream impact of your cloud workloads. We could implement lifecycle management policies with Amazon S3 to move data to lower cost, more energy efficient storage tiers and delete obsolete data. So this comprehensive approach ensures that your cloud architecture is well-rounded, balancing operational efficiency, security, reliability, performance, and sustainability. So all of these 6 pillars. I hope you found it useful, and thanks for watching.